Example number 4. The hyperbolic f of x is equal to 1 over x minus 1 minus 4 is given. Then the question is asking us in part A to draw the graph of f of x. And when we do that, we show all asymptotes and intercept with the x-axis. So first of all, write down the asymptotes. What are the asymptotes? Remember from grade 11, it will be x is equal to 1 and y is equal to minus 4. These are the asymptotes. Then we need the x cut, y is equal to 0. So it will be 0 is equal to 1 over x minus 1 minus 4. This one goes there. 4 will be equal to 1 over x minus 1. Cross multiplying. 4 into x minus 1 is equal to 1, which means our x minus 1 is equal to 1 over 4. And our x, therefore, is 1 plus 1 over 4, which gives us 5 over 4. Which means this graph will cut at 5 over 4 and 0. That is the x cut. And then the y cut, our x is equal to 0. It will be y is equal to 1 over 0 minus 1 minus 4. This gives us a minus 5, which means it's going to cut at 0 and minus 5. Now that is enough information for us to be able to sketch the graph. So let me sketch it before I bring in the inverse of it. Quickly, I'm going to use this information now to sketch the graph. X equal to 1. It is this here. I'll write x equal to 1. Y equal to minus 4. I'll put it there. Y equal to minus 4. These are the asymptotes that we have put on the xy plane. And then we need these points. There is 5 over 4, which is 1 1/4. Very close. This is 1, don't forget. And this is minus 5, don't forget. So it is right here. So we can write the coordinates here as 5 over 4 and 0. So we know it is approaching the asymptotes. So this will be the graph. We can show that it goes on and on. And then we also plot this point. It's 0 minus 5. 0 minus 5. Here I made a mistake. It's minus 4. Please take note of that. This is minus 4. So 0 and minus 5 is further down. So this point is minus 5 and 0. Again, the graph approaches the asymptotes and it does not cross the asymptotes. This is the representation of our graph f using the information that we have been given there. And it was saying, showing asymptotes, which we did show, and the intercepts with the axis. So we are done in as far as part A is concerned. Use the graph of f to draw the graph of f inverse. I'm now going to refer you to the graph that I drew earlier on. The blue is what I showed on this other page that I've removed here. The blue graph is the one that we had drawn, and please take note of that. Now we are saying the asymptotes were x is equal to y and y is equal to x. Very, very important. So we draw our y is equal to x first, so that we can now swap our x and y. It was x is equal to 1, so it means y is equal to 1 now. So y is equal to 1 is this, the one that I put in green. is the y is equal to 1. And originally it was y is equal to minus 4. Now it's x is equal to minus 4. The one that I put in purple. And then we now reflecting the main features. We had 5 and 0. Now it's 0 and 5 over 4. Sorry, it's 5 over 4 and 0. It's now 0 and 5 over 4. Then the red graph now is the one that is the inverse. And we also do the same with this part. It is cutting at minus 5, so it is now cutting at x is minus 5. So again is the red graph. So this is the inverse of f, which we have drawn. And the question was saying we put it together, and that's exactly what we have done there. Then part C says, give a reason why f of x is a function. You can see, if you are looking at this graph, it passes the vertical line test. Or you can say for every x value, there is a y value. We are still answering the same question. Then it says, write down the domain of f and f inverse. Very important again. We're now writing down the domain of f and f inverse. So we have f and f inverse. We are dealing with the domain now. Now, what is the domain of f? It will be x is a member of all real numbers, because x is satisfying all real numbers, except that x cannot be equal to 1. Very, very important for us to remember. And what is the y? You can see y is all real numbers as well. Y is a member of all real numbers, but our y should never be minus 4. Our y is never a minus 4. So this helps us to write our domain and range for f inverse. So it will be x is a member of all real numbers, taking it from there, and our x is never equal to minus 4. Then the range will be y is a member of all real numbers, and our y is never a minus 1, or is never a 1 positive. But in this question, we were only required to get the domain. So I just expanded your understanding by also doing the what? The range, please. We were not answering the question by finding the range. Part E, this was part D. Then part E is saying, write down the equation of f inverse in the form y is equal to. This is exactly the same thing. Our f of x is equal to 1 over x minus 1 minus 4. First step, we write f of x as y, then is equal to x, 1 over x minus 1 minus 4. Then we swap x and y. X will be equal to 1 over x minus 1 over y minus 1. We are swapping, remember, minus 1, then minus 4. We then take this that side. It will be x plus 4 is equal to 1 over y minus 1. Now at this point, we can cross multiply. It will be x plus 4 into y minus 1 is equal to 1. We take this that side. Y minus 1 will be equal to 1 over x plus 4. And therefore, we shall transfer this one that side. Y will be equal to 1 plus 1 over x plus 4. Therefore, our f inverse of x will be equal to 1 over x plus 4 plus a 1. This is our answer to that question. Exercise classwork will be exercise 3, numbers 1 and 3. Your homework will be exercise 3, numbers 2 and 4. Thank you.